Welcome to qnawire.
So first, I'm gonna reverse work the problem. I need to calculate the number of moles in my needed solution. And so the number of moles is for this is of course part A, is concentration times volume. And I have my concentration to be 1.53 times 10 to the power of minus 3 molarity, which is moles per liter. And then I have my volume is given as 57.5 milliliters. And of course, for unit consistency, I'm going to convert it to liters by dividing by 1000 or multiplying by 10 to the power of minus 3. So the unit is liters. And I get that the number of moles is 8.7975 times 10 to the power of minus 5 moles. The next step, so this is step number 1. The next step, step number 2, is to calculate the molecular weight of my chromium nitrate solution, which is the sum of the atomic mass of the constituent elements. For chromium, the atomic mass is 52, and then I have 3 of my ionic compound, so 3 of NO3. Nitrogen has 14, and oxygen has 16. I have 3 of them. And so this gives me 238, and the unit for the molecular weight is grams per mole. Now finally, the mass of chromium nitrate that's required would be the moles times MR. I've calculated the moles, which is 8.7975 times 10 to the power of minus 5 moles. And then my molecular weight is basically 238 grams per mole. These cancel out, and what I would get is 0.0209 grams, which is equivalent almost to 20.9 milligrams. For part B, I'm given a solution, and basically I need to dilute it by adding water. So first I'm gonna use the conversion that 1 meter cubed is 10 to the power of 3 liters. So first I'm gonna calculate the number of moles that's in my new solution. So number of moles is gonna be concentration times volume. The concentration is 1.45 molarity, which is moles per liter. And my volume is 5.8 times 10 to the power of 3 meter cubed. After converting it to liter, it becomes 10 to the power of 6 liters. You can see why I converted to cancel the liters, and I get 8.41 times 10 to the power of 6 moles. And so that's the number of moles in my new solution. All right. And this means that how much volume do I need from my old solution to contain such number of moles? So I'm going to use V equals moles, rearranging the equation over my concentration of my old solution. I've calculated the required number of moles to be 8.41 times 10 to the power of 6 moles. And the concentration is 2.5 moles per liter. I could see moles cancel out, and I would get that my required volume is 3.4 times 10 to the power of 6 liter, which is 3.4 times 10 to the power of 3 meter cubed. So basically I take this from